Next up, we have Aman Basu, who's a PhD student at York University, and he's going to talk a little bit about ice phenology.
Hello, my name is Aman, and I'm presenting this research on behalf of my co-authors. So, why is it important to understand lake ice phenology? Lake ice is being rapidly lost around the Northern Hemisphere. This is happening at rates that are 6 times faster in the past 25 years. Less lake ice can lead to higher evaporation rates in winter, along with the changes in water level, mixing regime, also warmer summer water temperatures. To put it simply, a warming climate can lead to partial or permanent ice loss that triggers warmer water temperature in summer, more algal blooms, less dissolved oxygen in water, and ultimately declining fish populations. The first question that we pose is how anomalies in ice on and ice off dates changing over time. Our second question is how do meteorological and lake morphological variables influence lake ice freeze-thaw dates? For this study, we collected in situ ice phenology data for over 2,500 lakes. Our time series ranged from 1443 to 2021. This panel shows ice on and ice off anomalies as deviation in days from the average date for these two metrics calculated over the last 50 years. For ice on, the blue bars indicate earlier freezing, while the red bar indicates later freezing dates, compared with the 50-year average. Similarly, for ice off, blue shows later date, while red indicate earlier thawing. We found a faster loss in the duration of total ice cover after 1990. To train and compare machine learning models, we use these meteorological and lake morphological variables for lakes with 20 or more years of time series data for ice on and ice off dates. After preliminary comparison were done, we found that the random forest model performed the best across all models in comparison of the evaluation matrices for both the ice on and ice off dates. After hyperparameter tuning, the random forest model, the predictive performance plot of the ice on dates and ice off date model reached adequate explanation power and reliability. As well, in the preliminary test for all the models and in the final tuned random forest model, the ice off date model performs significantly better than ice on models. Thus, we can predict lake thawing more accurately than freezing. When we arrange the model variables in descending order of importance from the top, both climate and lake characteristics were important. Air temperature was the most important driver of lake ice. Further questions for us include predicting future ice phenology changes under climate change scenarios and identifying lakes that are at higher risk of losing ice cover. Thank you. I'll be delighted to take any question.